liquid, gas. We all know the three states of matter. To convert the densely packed molecules of a solid into the loosely packed molecules of a liquid, the solid needs to absorb heat. The same goes for a liquid to a gas.
Wait, but what would happen if we add heat to a gas?
Well, we would get something called a plasma, aka the fourth state of matter.
Wait a minute, did you say another state of matter?
Correct.
A plasma is kind of like a gas, but it's composed of freely moving charged ions. It's formed when enough heat energy is added to neutral gas molecules, causing them to start ionizing. This is when some or all of the electrons are ripped away from the protons, giving the neutral atoms a positive charge.
Plasma? I've never heard of a fourth state of matter. Lightning?
That's right, plasma in its natural form.
But it's not even raining. You may not realize it, but
Plasma is all around us. From lightning to the northern lights to fluorescent lights and some TV screens. Plasma makes up approximately 99% of our whole universe.
a plasma is different from a gas because a plasma conducts electricity and responds to magnetic fields. So why does a plasma respond to magnetic fields?
Think of when an electrical current runs through a wire. In the wire, charged electrons flow freely opposite the current. Sound familiar? This is similar to the charged ions that flow freely through plasma. And because of special relativity, a magnetic field will be formed circling these moving electrons.
So if a magnetic field is created by moving charged particles and a plasma has moving charged particles, then a plasma has its very own magnetic field.
And similar to how you can use magnets to move some metals, you can use magnets to move plasma.
Because plasma is magnetic, we are able to make things like fusion energy possible. Plasma or nuclear fusion is the process by which two protons fuse together to create a heavier atomic nucleus while giving off a lot of energy. But although this process seems simple, for it to actually happen on Earth, it requires extreme conditions.
So protons have a positive charge. This makes them naturally repel other protons. This electrostatic force is known as the Coulomb barrier. Coulomb's law explains that the magnitude at which two particles attract or repel each other increases as they get closer.
Think of it like the protons are socially distancing themselves from each other, and the disease is fusion. In order to break this barrier and force the protons close enough together to fuse, we need a fusion reactor. This donut-shaped magnet provides a uniform magnetic field and applies high amounts of energy and pressure to the particles that allows them to fuse. So now that we know fusion energy is possible, and it's basically an unlimited source of power because it comes from hydrogen. But even after many years of research, there's still much investment needed to be done in order to get fusion on the market. Fusion is a clean and innovative source of energy. Fusion could be the future.